In this video, we're going to build a dash action for our player controller. Let's get started by downloading the project repo again so that we can grab the new image for the dash animation. Because the repo is stored with Git's LFS format, we need to clone the repo to get the images rather than just downloading the zip file. Once we have the repo, we can open the folder where we cloned it and then go back to Unity in order to easily open up the resources folder for our project. Now we want to go into the resources directory of the repo and find the player-image folder. Then we'll copy this into our project's resources folder. Then we can return the focus back to Unity and allow it to import the new image. Now we're going to make sure the image has the correct settings to work with our pixel art camera. The meta file should apply the correct settings, but we'll go over them in case you're using your own images. We need to make sure the pixels per unit is set to 16, and we also need a custom pivot at x equals 0.5 and y equals 0. Then we need to make sure under advanced settings that the filter mode is set to point, no filter, and the compression is set to none. Let's select our player prefab so that we can add a new animation clip using our dash image. After we open our player prefab, we can go to the animation window and then create a new clip by using the dropdown. We will navigate to the animation folder in our assets and then save this new clip as player dash. We'll set the samples to 10, and then we can drag the dash sprite onto the timeline to finish the clip setup. Now that we have a new animation clip ready, let's create the dash state script inside of our player state script folder. We'll open up this new script in Visual Studio, and then we'll get started by including it in our namespace. Then we can inherit from the player state base class. We can then ask Visual Studio to implement the constructor for us. Now let's include the init method for our state. We don't need to call the base class method because it is empty. Let's quickly jump over and include a new value in our player state type enum that represents our dash state. After we've included this new value, then we can open up the player script so that we can instantiate a new dash state in the player's state dictionary. We will follow the exact same approach we used to include the other states. We can now begin writing the init method for the dash state. We will start by using the player reference to begin our new dash animation clip. We're also going to set the gravity scale to 0 because this will give us a nice powerful horizontal dash that isn't dragged down by gravity. The next thing we need to do is introduce a new setting that defines the dash speed for the player. We can return to the dash state and apply this speed to the player when the dash state begins. The dash will work very similar to the jump action, but in a horizontal direction. We will apply a sudden change in velocity based on which direction the player is facing when they enter a dash input. We're also going to add in the player's current x velocity so that the dash adds to the speed they were already moving. This will ensure it always boosts the player forwards with the same sudden acceleration, regardless of whether the player was moving or not. Let's introduce the managed update method to check for when the player should exit the dash state. First, we'll call the update triggers method, and then we'll check to see if the player's x velocity has fallen back down to 40% of the dash speed. If this is true, then we'll set the player's state back to the move state. We also need to introduce the fixed update method so that we can apply smooth damping to make sure we are actually reducing the player's dash speed to ensure they will eventually hit the 40% marker and leave the dash state. We can copy the smooth damp function from the move state, and then we will set the target value to 0 exactly like we did with the duck state. This is pretty much all we need to do for the dash state script itself. Now we need to introduce the dash input action into our project so that the player has a way of entering the dash state from the move state. Let's find our player input actions asset, and then we can edit this asset to include the new dash action. We will first create a new action and then add a simple binding. For the first binding, we will use the Listen feature and enter the left Shift key on the keyboard. Then let's create a second simple binding for this new action, and we'll use the Listen feature to enter the X button on the controller. This is called the West button in Unity. Now that we have both bindings set up, we can save the assets so they are available in our project. Let's move over to the input system script and follow the same procedure we used to add our jump action. We'll create a variable for the action itself and then add a float variable to hold the previous value. In the awake method, we'll retrieve the action from the player input actions and then initialize the previous dash input to 0. We will copy the pull jump input function and use it to define a pull function for our dash input. It'll be the exact same logic, we'll just update all of the variables to match the dash action. Finally, let's call this pull function in the update method. Now we can move to the player state script so that we can define a set-input method that will allow us to store the dash input value in our input info component from any of our states. Remember, all of the player states inherit from this base class, so these virtual methods will all be available in our concrete states like the dash state. We will also have to move over to the input info component and add a float variable to hold the dash input value. We can now use the new set-input method to store the input value. Now our pull-input method in the input system will work correctly when it calls this new method. Let's also make sure to enable and disable the new dash action in the appropriate callbacks of our input system. Now our new input action is fully set up, so we can return to the move state script and implement the set-input method for this state. This will allow us to enter the player into the dash state when a dash input is received while they're in the move state. In this case, we will make sure to call the base class version of the method because it is not empty. Now we can check to see if the dash input was just pressed by making sure the value is equal to 1, and then we can enter the player into the dash state. We should now have a basic dash feature working for our player. So let's run the game and see how it works. First, I'll climb up to this long flat area to test it out. And then I can enter a dash input to see how the player reacts. So it looks like it's working, but the dash is pretty short. So let's open up the game settings scriptable object and increase the value to see if we can get a better looking dash. I'll set the value to 48, and I'm also going to change the ground and air smooth times to be the same value just to make testing out the dash feature easier since we can dash on the ground and in the air. That's much better looking, and you should also be able to see now that the dash animation is playing for the duration of the dash. The way we've set it up, the player is allowed to dash while in the air. If you only want them to be able to dash on the ground, then you can simply check the ground trigger of the player before moving them into the dash state. Okay, so the basic functionality is in place, but let's add an effect to the player so that it enhances the sense of speed during the dash. Often a game will have some kind of trail that appears behind the player to emphasize the speed of the player while they're dashing. We're going to open up the player prefab and add a trail renderer component to achieve this kind of effect in a very simple way. We want this to be a very quick effect to really highlight the speed of the dash, so we're going to decrease the time the trail is on screen to 0.3 of a second. We're also going to reduce the opacity of the second part of the color gradient to make it look like the trail fades away as the player moves. We're going to use the default line material, which is just a basic white material, and I'll also turn off the lighting calculations for the trail renderer because we don't need them for our purposes. Finally, let's change the graph that determines the width of the trail during its duration. To test it out, let's simply have it smoothly move down to 0 width. Let's run the game again just to get a sense of what the trail looks like. As you can see, the trail starts at the player's feet with its full width and a solid white color, and then it decreases in width and fades away as it moves away from the player. Right now, the trail is always active, so we'll also have to make sure that it only turns on during our dash effect. Let's fine-tune the width graph a little more. We're going to start with the width at 0 right at the player's feet, and then we'll quickly increase it to around 0.4, then allow it to slowly decrease down to 0 again as it fades away. Now let's run the game again and see how this has affected the trail. You can see the trail has a smaller width overall, and it also begins at a single point from the player's feet before expanding. I'm going to go back and lower the time a bit more to 0.2 seconds, and I'll also turn off the emitting option. This will ensure that the trail is not always active. Now we'll need to make sure that our dash state activates the trail when it starts up, and then deactivates it again when the dash is over. To do this, we are going to introduce a trail renderer reference into the dash state itself, because the state should be able to handle the entire management of the trail. Since the dash state is not a Unity component, we will have to use the player reference to get the component. For this, we will use the constructor of one of our states for the first time, because we only want to grab this reference once at the beginning. We don't want to reset the reference every time the dash state is initialized because it never changes. Now that we have access to the trail renderer, we can use it to turn on the emitting property whenever the state is initialized. And then we can also use it to turn off the emitting property whenever the player enters back into the move state. And that's all it takes. We can run the game again and test this out. We can see that the player starts out with no trail appearing behind them, and then if we start using the dash ability, the trail appears nicely behind the player just for the duration of the dash. That completes our new dash state. We're going to do one more thing in this video. There's a bug that occurs when the player is climbing a ladder. The problem is that when the player jumps on a ladder while they are climbing, they enter back into the climb state so fast that the animation gets messed up. Basically, jumping enters them into the move state, and that starts the idle animation, but then they immediately re-enter the climb state when they grab the ladder again. This all happens so quickly that the idle animation ends up playing instead of allowing them to return to the climb animation. To avoid this, we can do something similar to what we did with the hang state. We will set up a timer that prevents the player from returning to the climb state until the timer has completed. Let's start by introducing a new game settings variable that holds the wait time for climbing. And we're also going to rename the hang before climb time variable to make these two consistent, because they are essentially the same feature just applied to different states. We'll now introduce a couple properties into the player script to track these timers. First, we'll define two Boolean properties that return whether the player has waited long enough to be able to enter these states again. We'll call the first property canClimb and the second property canClimbLedge. We will also create two float variables to store the time at which the player is able to enter these states again. We will call these properties canClimbAt and canClimbLedgeAt, and we will define these properties with a private getter and a public setter. This is because we want the player states to be able to set these timers, but we only need the player class itself to actually get these values. All other classes can simply refer to the Boolean variables if they want to know whether the player is eligible to enter a state. We'll finish the Boolean properties by returning whether the current time is greater than or equal to the time that is set in the float variables. Now we're going to introduce a new technique because the player can exit the climb state in a number of different ways, so it would be a little messy to reset the timer at all of these different places in the code. Instead, we're going to use the setState method itself. Whenever the player is setting a new state, we'll first check to see if they are exiting the climb state, and if they are, then we'll set the canClimbAt timer to the appropriate value. This will be the current time plus the amount of time we want to wait until they can climb again. Now our player's Boolean property should work correctly for the climb timer. We can go to the move state and then check this property before allowing the player to enter the climb state. Let's test this out. If we get back up on this ladder and attempt to jump while climbing up the ladder, we should see that the bug is now gone, and instead the player jumps a very short distance and then grabs the ladder again. This is because they are prevented from immediately entering the climb state again by the timer. To finish this video, let's just update our climb ledge timer so that it works in exactly the same way. In the hang state, let's delete the private variable we were using to track this wait time, and instead we will set the player's can climb ledge at variable in the init method. The last thing we need to do is check the correct Boolean property on the player before allowing them to climb up the ledge after hanging on it. If we test this out, the timer should work exactly like it was working before. The only difference is that now it is handled in the same way that our new climb timer is handled. That's all we're going to cover in this video. Please remember to request any new features you're interested in seeing in the comments. Thanks for watching.